Hey guys, BuildZoid here, and today we're going to be taking a look at how I repaired this here RTX 2060 Super. So first here's proof that the card does in fact function. So it passed the Unigen superposition stress test. It passed it twice, but the thing is this isn't really a priority due to the type of failure that the card had, which we'll get to. But anyway, while running superposition, it maxed out at 75.6 degrees Celsius, which is roughly what you'd expect considering that this is like a really cost-optimized RTX 2060 Super design. It's got a backplate, but that backplate is made of plastic, and the heatsink only has 3 heat pipes in it. So for a card that pulls, a little under 200 watts of power, 75 degrees Celsius seems sensible considering that it's also only going up to 2300 RPM. So it's not loud, but it's also not super cool. But, like, what would you expect from a card like this? Anyway, yeah, so it passed superposition, and also it's been just sitting, running in this system for the last day and 22 hours. So, healthy card, especially considering the type of failure that this card had. Like it's fixed. So anyway, let's take a look at what was wrong with the card. So here we have the PCB, and I apparently didn't. Okay, yeah. So here we have the PCB, and the first thing you should do with any non-functional GPU is not turn it on. It's check that there are no short circuits on the card. Now, this card, while a cost-optimized take on a 2060 Super, does still have fuses because Pallet is one of the very few manufacturers who does a good job of putting fuses on all of their cards. There are some there's also manufacturers like Asus who just do not believe in the concept of fuses. Though funnily enough, like GTX 500 series Asus cards, those had fuses. And then the 600 series Asus just stopped using fuses, and I've never seen a fuse on a Asus GPU since. But anyway, yeah, Pallet is one of the manufacturers that does put fuses on a lot of their cards, if not all of their cards, and so that makes troubleshooting, that makes it far less likely for the card to suffer like extreme amounts of damage from a power delivery failure. But in this case, that's not relevant at all, as neither of the fuses blew because there's not really any, we didn't suffer a catastrophic power delivery. Well, technically, the card did have a power delivery failure, but it wasn't like a catastrophic power delivery failure, which is why the fuses didn't end up blowing, because, yeah, we'll get to that. Anyway, so to check that the fuses are good, you just measure the resistance across them, and you should just get a nice low resistance measurement. Keep in mind that when you're taking resistance measurement, your probes have like contact resistance. So yeah, like even if you're measuring something that's even if you're measuring like a 5 milliohm shunt resistor, your multimeter won't tell you that it's 5 milliohms of resistance. Anyway, so after checking that the fuses are good, you still want to check that there isn't short circuits on the 12-volt power rails, which is what the fuses are connected to, because I have run into GPUs where they'd have fuses and there was a short circuit, but the fuses didn't blow. So the fuses are not infallible. They can sometimes fail to blow when they should blow. So for that, on this card, you could just measure from the fuse to the ground, somewhere like a screw hole. Or on most NVIDIA GPUs, I like to use the shunt resistors because those are a very convenient place to measure 12 volts from. Anyway, and you need to do that separately for both your, 8-pin, like any auxiliary power connectors, as well as your PCIe slot 12 volts, because those power planes are generally not combined on the card. For reasons that we're not going to get into. You also want to check that your 3.3 volts isn't shorted, but I've forgotten which pin the 3.3 volts is on. As I normally check 3.3 volts off of a capacitor, I don't have a picture of the back of the card. Anyway, you can look up the pinout of a PCIe slot on Wikipedia. Seriously, with some of the questions I get, I wonder if people have ever heard of Google. Anyway, so there's no short circuits on the 12 volts or like 3.3 volt rail of this card. So next we need to check all of the minor power rails that the card itself generates. So things like the memory VRM over here. For this, you just take for this I just take a measurement right across these output filtering capacitors. This card uses Samsung GDDR6, which has a very low resistance. And so the memory rail on this card had a resistance of just 8 ohms, which is really low. When I saw that, I was first worried that it was like that the card had a memory issue, but nah, Samsung GDDR6 is just extremely low resistance. Anyway, Up here we have the 1.8 volts and PEX rail. I think this is 1.8. I think this is PEX. The 1.8 volt rail on this card was between 1 and 2 kilo ohms, which is a healthy measurement for a 1.8 volt rail. And the PEX rail was, I think, 13 ohms. Which, yeah, is kind of weird because normally you'd expect the PEX rail to be lower than your memory rail, but Samsung GDDR6 is special. So anyway, this was at 13 ohms, and that's healthy for a PEX rail. V-core to ground was 0.3 ohms, which is very low, but that's totally normal for modern large pieces of silicon like this. Actually, it doesn't even need to be modern. Like a GTX 580, a healthy GTX 580 has a core resistance of 0.5 ohms as well. And then you also have cards like, say, a GTX 1080 Ti, where the core resistance is, if I'm not mistaken, 0.08 ohms, and Vega cards are like 0.15. So a lot of basically V-core on most cards has a very, very low resistance. And so if you're going to be checking your V-core resistance with a multimeter, you're going to need to use a multimeter that goes like 0.00 for the resistance resolution, because otherwise you're just not going to see anything. Though admittedly there are also cards where the core resistance can be in the like single ohm range, so like 1 to 10 ohms. Yeah, for most modern GPUs, the core resistance tends to be very, very low. Anyway, so, nothing wrong with V-core, nothing wrong with 1.8 PEX or memory power or any of the 12 volts or 3.3 volts on this card. And the last thing we need to check is the 5-volt regulator over here. Either side of the inductor for that thing is fine, and then like over here, since we're near the display outputs are a really nice, display output casings are grounded and they're soldered directly into the ground plane of the GPU. So these have a really nice, good connection to the ground, at least if you're taking resistance measurement. Technically, the PCIe bracket itself is also grounded, but because this is just screwed into the card, on especially old GPUs, this will be like over time the metal will just corrode and stuff. And if you try to take a resistance measurement from the PCIe bracket, it can sometimes be kind of inconsistent because the bracket doesn't actually have that great a connection to the internal ground plane of the GPU. So I generally screw holes are good, display casings are good, PCIe brackets are convenient, but not necessarily always super reliable for getting a good ground connection. Anyway, either the measurement from this to the ground of the card was like 5 to 6 kilo ohms, and that is a healthy resistance for the 5-volt rail. So this card had nothing obviously wrong with it, right? There's no short circuits, and so it's safe. There's no short circuits, there's no abnormally low resistances, and so it's safe to turn it on. So I tried to turn it on, and nothing turns on. And when I say I didn't have the fans connected at that point, because this is one thing I always find funny, where it's like I'll see people say, "Oh, I have a GPU that doesn't put out an image, but the fans spin," and it's like, well, that generally doesn't really mean anything. There's one scenario where if the fans are at 100% fan speed, that normally indicates that the GPU core died. But for anything else, if the fans are spinning, that doesn't mean anything. So, yeah. But anyway, so I don't know if the fans were spinning. I also don't care because it doesn't matter. I tried to turn the card on, and nothing turned on. There was no memory power, there was no PEX power, there was no 1.8 volts, there was no V-core, and there was no 5 volts. And the fact that there was no 5 volts is the reason why everything else didn't turn on, because on the vast majority of GPUs, if there is a 5-volt regulator on the card, that 5-volt regulator is there to power things like your power stages, voltage regulators like this over here, well, not this, but potentially this chip over here. A lot of the voltage controllers on various NVIDIA cards actually run off of 5 volts, or I'm not sure that it's their primary power supply, but they do take 5 volts. And so if your 5-volt rail is missing, potentially most, if not all of the voltage regulators on the card are incapable of functioning because they need 5 volts to function. Which is why there's a 5-volt rail. And so the 5-volt rail not turning on this card is the reason why nothing else turned on. So that led me to investigating the area around the 5-volt rail more closely, and I noticed that this capacitor over here was not looking particularly healthy. A healthy multi-layer ceramic capacitor should basically be one continuous color from, each terminal to the other, and this one was not. Because it cracked. And so it looked, kind of suspicious. It looked off because there was a crack in it. So I measured the resistance of that capacitor, and of course, being a cracked multi-layer ceramic capacitor, it was shorted out because that's typically what ends up happening if you crack a multi-layer ceramic. It internally shorts out, and so I removed the cracked capacitor. This unfortunately did not fix the 5-volt power rail missing because there was other issues, but yeah, so that's like the first issue that the card had was this cracked capacitor. Now, to try get the card to turn on, I also tried to externally power it with an external 5-volt rail, because I wasn't sure if this maybe was misbehaving or why this is misbehaving, because unfortunately this label on this chip, this is a Richtech label, and Richtech labels are terrible because you can't Google this. If you try to Google this, you will not find anything. So what you need to do if you want to identify a Richtech component is go to Richtech's website and then try to guess what the component probably is, and then go searching through the PDFs, and if you're lucky it'll be public. If you're unlucky, it won't be public and you'll never find it. So yeah, I absolutely hate Richtech voltage regulators because they're impossible to, actually Richtech anything, because it's impossible to identify quickly. So I was doing everything blind. I don't have schematics for this card, and I don't even have a data sheet for this chip over here. So yeah, I decided to try get the card to turn on with an external 5-volt rail. That didn't work, but that's also why we have the solder over here. And why this inductor is a bit messed up, because I lifted it off in order to feed in the external 5 volts. But anyway, that didn't work for some reason. Probably because this thing sends out a power good signal to the rest of the card to indicate, hey, it's safe to turn on now. So if you're trying to externally power this, if for some reason this thing died, it didn't. But if this did die, you would probably have to, and you don't want to replace it with the same component, you might have to actually find a power good signal on the, have to provide a power good signal to the GPU, because this does seem to produce something like that. But anyway, so that attempt to get the card to turn on failed, and so I went back to sort of investigating the area, and I got a bit suspicious of this 000 ohm, this 000 resistor, which is a 0 ohm resistor. And 0 ohm resistors, especially large ones like this, are typically used for power distribution, as in they are used to connect things to 12 volts, 3.3 volts, that kind of thing. They're, yeah, they're used for power distribution, basically. And this one connects to the 12 volts of the PCIe slot, and actually we should probably go back to here for this. So yeah, this resistor right here on one side connects to this fuse, and on the other side it connects to over here. But I figured that out way later. But basically, I noticed the 0 ohm resistor. I was like, well, it's a power distribution resistor, and we had a short circuit in this area of the card that didn't trip the fuses. Maybe this resistor burnt out. So I measured the resistance of that 0 ohm resistor, and it wasn't 0 ohms, it was 3 kilo ohms, which is very much not the resistance it's supposed to be. So the next thing I did was I put a fuse across it. This is a 1 amp fuse that I stole off of a dead HD7970. And the reason I put a fuse across it instead of just immediately replacing the resistor or putting a jumper over it is because I wasn't certain that I didn't miss any other defects on the card. And I didn't want to potentially, especially if you use just a jumper wire, you could potentially just burn a hole in the card if there was some other issue somewhere that you didn't notice. So I put the 1 amp fuse across the resistor, and card turns on, because the reason why our 5-volt regulator wasn't turning on was in fact that it wasn't getting 12 volts, because the 0 ohm resistor that is supposed to connect our regulator to 12 volts was burnt out, and it was burnt out because that capacitor cracked. So, after basically getting this to turn on with the fuse installed, I decided, okay, we're just going to replace the failed 0 ohm resistor with a salvaged 0 ohm resistor from a GTX 480. and a new multi-layer ceramic capacitor from the input filter of the V-Core VRM of an HD7970. The main thing here is that like you need a capacitor that's meant for power filtering off of a 12 volt power rails. This thing takes in 12 volts, converts it to 5. So this, which was intended for the V-Core VRM of a 7970 is a perfectly good replacement. Actually, this capacitor is probably better than what was originally here. But I'm just guessing at that point. So yeah, a very like relatively easy fix. Also, I didn't leave the card in this state before assembling this. Obviously, I cleaned it. This is unacceptable. This is disgusting. There's flux everywhere. So yeah, I didn't put the card back together with it looking like this, but I cleaned it up and I didn't take a picture of the card like right before assembly. So I don't have one to show you, but I didn't leave it like this because, yeah. Anyway, like I do admittedly use a no clean flux, so it's not like I had to clean it, but I don't, yeah, I don't particularly like leaving cards dirty like this. There are fluxes that are corrosive, and with those you have to clean, because if you just leave them on the PCB, they're going to destroy everything. So, and I point that out because I have had a card come in where somebody tried to use like they used a corrosive flux and just the entire area was just dissolved, basically. Yeah. Anyway, where was I going with this? Right. So easy fix, right? New 0 ohm resist. Well, salvaged 0 ohm resistor, salvaged input filtering capacitor, and the 5 volt regulator works again. As for why the capacitor would crack, I have no idea. Multi-layer ceramic capacitors are generally very like electrically robust, thermally robust. The only thing they don't like is physical stress, especially bending, because they're made of ceramic, so they're very, very rigid. And so if the PCB around them bends, they don't bend with it. So that can either lead to like the terminals coming off of them, which is bad, but the worst scenario is when the actual ceramic itself cracks, which shorts out the internal layers of the capacitor. And well, if you're out like here, this didn't cause any serious damage because that capacitor shorted out, and this resistor over here can't handle like that much current, so this resistor just burnt up, and that capacitor didn't really do anything drastic. However, you can sometimes have like a input filtering capacitor that's like right on the 12 volt power rail. And if one of those cracks, right, like if there's nothing that'll limit the current before the resistor, before the capacitor, if one of those cracks, it can just burn a hole right into the PCB because it'll just keep pulling current until either the power supply's overcurrent protection trips or the capacitor burns itself into like burns itself out. So yeah, this was kind of lucky for a cracked capacitor to be just sort of, behind a resistor like this, because let's say, actually, I don't have a picture of the back of the card, so I'm trying to find one that's connected directly to 12 volts. Oh yeah, these guys over here. These are directly connected to 12 volts. So, and the reason these are directly connected to 12 volts is that these are filtering for the memory VRM, and we can't have like a resistance, like the memory VRM pulls a significant amount of current. You can't have a resistance in front of it. This resistor is here because this regulator is never going to output more than like an amp or something. Actually, I'd be very surprised if it ever put out even an amp. But so, it's okay to have this like small power distribution resistor that acts a bit like a fuse when something goes wrong. But you can't do that in front of the a memory VRM, which is why you have fuses like this on the card. Like you have actual proper fuses, but if the card didn't have fuses, which a lot of GPUs don't, and you had, say, one of these capacitors crack, like that cap is just going to pull current until your overcurrent protection trips. And in the process, it is going to get very, very hot. Like hot enough to weld itself to the PCB is... And when I say weld itself, I mean weld. Like it'll become one with the copper layer. Potentially. So yeah, that's kind of the thing with cracked capacitors, is they can cause spectacular amounts of damage. So it's kind of lucky that this one was just like, a one that had a 0 ohm resistor in front of it. I still don't get why it cracked though. Like it doesn't make any sense to me because it's not super like it's like if you're going to have a ceramic capacitor crack, it's typically because it's near a screw hole or something that like maybe near a display output because the PCB in that area might be under physical stress from the connector or the screw, that kind of thing. I guess this one is kind of close to the VRM, so maybe the thermal pad was bending the PCB in the area a bit and then the capacitor cracked, but that is very rare. So maybe it was just unlucky and it got like dropped in manufacturing or something. Because that is another thing is like those multi-layer ceramics can develop like micro cracks if they just suffer some kind of physical shock in manufacturing, or it wasn't soldered quite right, or it cooled down too quickly. Like, and so it developed a crack, and over time it eventually just kind of destroyed itself and then burnt out this resistor. Um, but yeah, the card's now fixed. So yeah, it works. Um, Relatively simple fix. It took me a while to figure out like why the 5-volt regulator doesn't turn on, but considering I don't have schematics or a pinout for this chip, simple fix. I didn't have to go look up the schematics for this thing. So I mean, didn't have to go look up even a pinout for the 5-volt regulator. So the fact that I could do it that way is just kind of like, yep, that's kind of nice. Though I do wonder if maybe just looking up the regulator wouldn't have been faster than sort of trying to guess, like intuitively guessing that, hey, this resistor might not be doing so good considering, this cap died. Um, but yeah, so that's it for the video. And thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, hoodies, posters, the usual YouTuber merch. And I also have a Bandcamp if you want to check that out. There's a link to that down in the description below as well. So yeah, that's it for the video. Thanks for watching and goodbye.